Welcome. I was recently thinking about chess in higher dimensions. I have here a 3D chess, but very cool would be a chess on an 8x8x8 board where you have 64 pawns and lots and lots and lots of figures. Would love to see a simulation of this game with 28 rooks on each side. An example of a Earth-made game, a man-made game. It is not natural. We can define many different games. Even here, Bobby Fischer has looked at all the 960 possible permutations, which have some rules, like that the king has to be between two rooks, and they are just exactly 960 different cases, but still we have the rules are rather arbitrary, the figures are rather arbitrary, the number 8 is rather arbitrary, the dimension is rather arbitrary, the topology is rather arbitrary. We can look at it on a three-dimensional torus, we can look at it on a three-dimensional manifold with other identifications. So there's lots and lots of choice. On the other hand, if you look at axiom systems, like the algebraic structures which we have, like group-like or ring-like or algebra-type structures, there is very little choice. On another planet like Andromeda, there would be another civilization would come up with that. So there is no question that this is really, these are very natural systems, and especially if you get to more, specific structures like division algebras. One of the beautiful things is that we have now almost no choice. So if you look at commutative real associative division algebras, there's only one choice, and if you have non-commutative real associative division algebra, there's only one choice. And then you can quantize things. You can look at integers. When you look at integers, you get more into particle-like structures, like you count the number of things. Particles are discrete. And then there is kind of a nice, coincidence that you have C-lepton type structures in C, and you see hadron-like structures. You see mesons or baryons. This is a mathematical result. And then you see mesons, the equivalence classes with 2 elements, or baryons with 3 elements. For every prime, we can modulo the symmetry. We can just essentially nail it down to an integer configuration which we can evolve. And I was thinking just the last couple of weeks again at evolution on simplicial complexes, which is a geodesic evolution. And now the natural question, of course, is, can we play that game more interestingly? Quaternion integers running through such a geometric structure, can we kind of make an interaction in such a way that we see something like the standard model? Anyway, one has to be careful, like there is on the Rubik cube, you can find mesons and you can find baryons. It's an old theme, right, of also Kepler in his Harmonicis Mundi was seeing Platonic solids in the planets, right? Platonic solids, planets. It's very natural to make this association. And Euler thought about beauty. George Birkhoff here, 1933, made a whole course about beauty, about aesthetic measures. So what is beautiful, what is natural? And this occurs when you design a game, this occurs when you design an axiom system in mathematics, or when you kind of look at physical models. Physical models are never really cover the whole thing. They are just in certain domain they are well. But if you look at the Lagrangian of the standard model, this is just butt ugly. This is definitely human-made. So this is a perturbation thing. We just, it's very successful. We have it, but there are lots and lots of gaps, right? Neutrini, for example, they have mass and in reality, and there are oscillations of neutrini and all kinds of things which are not explained in the standard model. So it's also just a model. It's very successful, but it's a model, and it's definitely not the ultimate description of the standard model. Now the question is there something which kind of allows us to play that game in a simpler way. And chess is a nice allegory, because chess is by itself, a game which has little to do with, wars and conflicts in general, but there are affinities, right? There are structures, there are the soldiers, and there are more powerful figures in a battle, and there are powerful figures like the queen, and so there are horses which can do different things. So it's a very beautiful kind of allegory, but it's not natural in the sense that it's inevitable. And what is nice about this, and I'm of course not the first to point this out, there's a whole talk of Artea about this, kind of that the division algebras are really a natural thing to consider when you look at particles, because there is SU2, there is U1, there is SU3 as a symmetry coming in naturally. There's no SU5 or SU6 or SU7 coming in. So it's a kind of a nice quest to look at games which maybe have some features of the standard model. And that's what I want to do. I want to evolve Gaussian integers, I want to evolve quaternion integers, and with a cellular automata type interaction. The question is, what do you do with the interaction? That's it for today. Thank you.